Hello and welcome to an Edexcel iGCSE Computer Science past paper. This is paper 2, Application of Computational Thinking. So this paper is the practical paper, but there's also some theory side to it as well. So you write on the paper and hand in your exam files. So with this paper, you get the exam files, which are linked to down in the description, to my Dropbox account in Python. The total mark for this paper is out of 80. So this complements the paper 1, again listed down in the description, to give a total mark of 160 for the final GCSE. So of this GCSE, 50% is this exam, 50% is paper 1. So some sound advice there at the bottom to read each question carefully. The amount of marks that are lost from students not reading the question carefully, just jumping in straight away and answering what they think is the question, it isn't the question. They might have done a perfectly good answer for what they thought was the question, but that it actually isn't the question they were supposed to be answering, so they've lost marks there. So make sure you do read it properly. Save your work regularly, absolutely, and check your answers if you have time at the end. You get 3 hours for this paper. Now, in my experience, you do actually need that 3 hours. So of that 3 hours, you should try and break it down as much as possible into allowing the most amount of time for the big question at the end, which is worth 20 marks. So I'd allow about an hour for that, and I'd allow 15 minutes just to check everything through. So ideally, you should be finishing questions 1 to 4 or 1 to 5 within about 2 hours, under 2 hours. So we'll get started, but before we do, I need a favour from you. Please, if you haven't already, like this video and please press the subscribe button. It encourages me to make more videos and I really appreciate it. So thank you. So make sure you check the right box here. It's Python. Question 1. Programmers write code to solve problems. Identify the description of a variable in a computer program. Is it A, B, C or D? Is of course D, a value that can change. It can be used more than once, it doesn't have to be input, and it's not always used in a calculation, so it's simply a value that can change. B. Identify the technique that improves readability of code. It's A, B, C or D. It's not indents on every line if it's not appropriate. It's not correct using the correct operators, because that's not improving the readability of code. It's not using suitable data structures. It is using B, using descriptive names for variables. C. Complete the table giving an example for each data type. The first row has been completed for you. Integer, 12. So char, that just needs to be a single letter. So I've chosen A there, and real, that needs to have a decimal point. So 1.25 for example. D. Describe one difference between the data used in boundary testing and the data used in erroneous testing. So boundary testing data is data that is at the extreme ranges, so extreme ends of the range. And erroneous testing data is data that is completely outside the range, so completely invalid data. E. A program should output the value 2. However, there is an error in the code and the actual output is 4. Name this type of error. Well, this isn't a syntax error because it's not anything to do with breaking the rules of the syntax. It's not a runtime error because it's not something, for example, like finding a file. It is a logical error. F. Open Q01F in the code editor. This is Q01F here, so links in the description. The program should allow the input of the length of the side of a square and output the area of the square. There are 3 errors in the code. Amend the code to correct the errors. Save the program as Q01F when you finished it. So first thing to do is to actually save that before we do anything else. So we'll save it first as Q01F finished. Now in every single exam there's a question like this where you've got some code that doesn't work, we need to fix it, and the easiest way to fix it is probably to run the program. You might see that immediately you can spot errors in there. Error is equals length times length. That doesn't look right, does it? But we'll run the code first to see where the errors are. But you might be able to spot them immediately. If you can spot them immediately, then fix them right away. But I'm going to run that module and see what happens. So invalid syntax first off here. So it's saying invalid syntax on this line, but it actually could be the line before. And if you look at the line before, you might be able to spot that. Length equals float, brackets input, open brackets. Now we've opened two brackets, but have we closed two brackets? So no, so we closed both brackets there, and then can save that and run that again. So run module, and we need to save it, and we can run it again. So now we've gone past that syntax error, and to the length of a side, 4. So another error here, name area is not defined, line 5. So if we look at this here, print the area of the square is area, but we cannot see area there. So we take out the quotation marks there, and that should actually go in here. The area of the square is area. So run that again. There's still an error here, length not defined. Look at this. This is a comparison operator. So this is our third error that we need to fix. Area equals length times length. Now what's wrong with that? Well, that's a comparison there. If length is equal to length times length, well, area hasn't been defined yet. So what we need to do is get rid of one of those equal signs. So area then becomes length times length. Area is now defined as length times length. So now we'll save that and run that again, and it should work. To continue with our test data for, the area of the square is 16.0. Brilliant, that works. Okay, so the quickest way to fix those errors is to actually run the code and see what's actually wrong with it. We'll move on to G. A program is needed that will accept the input of a letter and compare it with the stored letter. It will check whether the letter comes earlier in the alphabet, later in the alphabet, or is the same letter as the stored letter. It will output the letter and the stored letter with an appropriate message. Open Q01G. So here it's Q01G, and you can see you've got stored letter equals G, letter equals input, enter a letter, input a letter, sorry, and then letter equals letter dot lower. So that converts it to lowercase, that dot lower. Amend the code by completing the if statement. So your work here is the if statement. If, elif, and then else. So it's going to check if the letter comes earlier in the alphabet, later in the alphabet, or is the same, and then output the result. So we'll look at this. So it will check whether the letter comes earlier in the alphabet, later in the alphabet. So first we're going to check if it's later in the alphabet. So if letter, which is the input, is greater than stored letter is G. So what if that is true, colon, then I'm going to print letter is later in the alphabet than stored letter. So if it's greater than letter, then it's later in the alphabet than the stored letter. So if, for example, it was M, that would be later in the alphabet. So as you go, you can actually run this and just see what happens. So first off, we need to save it as Q01G finished. Now it won't actually let me run it because, of course, I get syntax out because I haven't done my elif here. So let's do the elif. So if letter is the same as the stored letter, so the operator we need is equals stored letter, then what we're going to do is print that out of. So print letter, so letter input, is the same as stored letter. Now you notice we're using the plus, not the comma here. We've got that string there, we don't use the comma, so we can use the plus symbol. And now we need to do our else. So else, it's going to be earlier. So print, if it doesn't meet any of those two conditions, it's going to be earlier. So letter and is earlier, make sure I spell it correctly, in the alphabet than stored letter. So now we run that, obviously save that as we go. Let's input the letter M. M is later in the alphabet than G, yeah, good. It's just, I don't like that. There's not a space there, so we'll just fix that. There should be a space in there, otherwise it doesn't kind of concatenates the two together. So this is a concatenation here, and it concatenates that. So M is, so it looks like Ms is later in the alphabet than G. Let's try it with some other data now. What about we'll input G just to test it. G is the same as G, yeah, absolutely it is. And now we'll try another one, we'll try the letter A, and it should say it's earlier. So if you've got time, do test your code. Definitely as a minimum, run it, don't just assume it's going to work. So amount of students I see just hand it in, they haven't even tested it, they haven't even pressed F5 yet to run it. Well, what if it doesn't work? You think you've got your marks there, you think you've secured your marks, but you haven't. I would always test it with three inputs there if we've got 3 tests to do. Why? Because you need to secure these marks before you move on. These are easy marks, so let's secure them and make sure we've got them. And that completes question 1 there. 4 marks, this is 4 marks, and that's a total of 14 marks out of 80. 2. Raza is writing a program to tell the user whether a number they input is a prime number. A prime number is a whole number, a larger than 1 that can be divided by 1 and itself with no remainder. The pseudocode contains the logic required to complete the program. So I've just zoomed it out so you can see the full code there. There's 24 lines and this is what you need to code. There's usually a one-to-one translation between what's here and the Python code that you need to write. So we're going to program that in question B, but for question A we need to answer some questions about the pseudocode. A1, identify a line number where selection starts. Selection is if, and we can see that on line 3. You could also have line 8, and if we scroll down, we'll also see selection on line 20. So I'm going to just simply choose line 3. 2, identify the line number where iteration starts. So we're looking for for loops or while loops. And if we look at our code here, we can see a for loop on line 7. So I'm choosing line 7 as my answer there. 3, identify a line number where a string and a number are printed on the same line. So where can we see that? A string and a number on the same line. So we look down here, line 21, number and is a prime number to display. So I'm going to go with line 21. You could also have line 23, number and is not a prime number to display. So I'm going with line 21, which is a great number because that's my age. 4, identify the name of a local variable. So we go and have a look at this. Where can we see a local variable? So we need to look inside the function there. And we can see p number is a good example there. You could also have check in there as well. Or you could have, you've got in there account. You could have that as well. I'm just going to go with p number. So local variable should be within inside the subroutine. 5, identify the name of a parameter. So that is what has been passed into the subroutine. And that is between these brackets. That is a parameter there. So this, in the brackets, is a parameter. So I'm going to write down there p number because that's the answer to that. That's the parameter that's being passed into the subroutine. And that is p number again. So now we go to B and you need to program logic from the pseudocode into Python. So this is all you're given for this. Q02B, write your function here, write the main program here. So within these comments, we've got to write our code. So we'll go ahead and do that now. So we'll go back and look at the pseudocode to be able to do that. So we've got line 1 there, function, check prime. Okay, so to define a function in Python, we write def, which means define, and you must call it the name of the function that's given there, which is check prime with a capital P, then camel case there, and that's p number. Again, capital N, so you've got the camel case there. And we must write a colon. As soon as we press colon, when we press return now, it indents automatically the code. So if p number is equal to 1, so it's a comparison there. We're not assigning 1 to the variable p number, we're making a comparison. So if p number is equal to 1, then check equals false. False should be capital F. So that's fairly straightforward. The code is almost identical to the pseudocode. Now we need an else, so we go back and we need to write colon, else, check equals true. Again, the capitals, and true should go orange like false did. So now we're into a for loop. For count, from 2 to p number do. So for count, now we don't just write from 1 to p number or 2 to p number do. We write count in range here like this, 2 to p number. So for count in range, 2 to p number. If p number mod count equals 0, then check equals false. So now our if p number. Now to do the mod function, write percentage count. So p number mod count, so that's percentage in Python. Comparison is equal to 0. Then check is equal to false. Now we can go back here and we can return check end function. So we've written our function there. Now we need our main code. So we go down to line 16, send enter a number to display. So number equals int input, and then we need to enter a number. Space, close both brackets. So that actually covers line 16 and 17 because we don't need to receive number from integer keyboard. We've now got that. We've done that in 2 lines of code in 1, which you should always do if possible. So now we can go to line 18, set result to check number prime. So result equals check number, check prime, apologies, number. So that is calling the function there, check prime. So if what comes back from that, so the return, if result equals true, so coming back from our function, if the result we get back is true, print number is a prime, number is a prime number, else print number is not a prime number. Now I just put some spaces in there, so otherwise that's not going to look too good. So that is our code written, so we'll save it as Q02B finished and then we'll run it. Now I did run it and I've got an error. P number is not defined. So these are the things, this is why you should always check your code, not just assume it's going to work. So I found that I've got an error here. It's line 17, P number is not defined. So it says line 17, but I can't see the error here. What that's actually doing is calling this function here. So the error is actually in the function. And if I look down to here, line 9, and I can see line 9 down at the bottom there, it says line 9. Here we can see the problem. That should be P number there. So I'm going to save that and run that again. So I entered a prime 2 and it told me it's a prime number. So we could try that again with a non-prime number. So I tried that with 4 and that told me it's not a prime number. I'm not too keen on the spacing here, so I might just adjust that. So I don't actually need that space in there like that. It doesn't actually look that good. So what we've learned from that then is always run your code, because I found a very silly syntax error that could stop my code from running. If your program doesn't work, you can still get marks, because if it doesn't work, then the examiner will go through each individual element and check it through. So you get marks for what you do, but obviously you're going to get the most marks for the code that works. It's not the end of the world if the code doesn't work. If your code doesn't work, perhaps try considering commenting out sections of the code. So if the function didn't work there, I might comment it out and just see what I needed to do to get that working, or comment out certain sections of the code. So that completes question 2 there. And question 2 is worth a total of 16 marks. Question 3. Manjit sells copies of science textbooks to schools. She needs a program to process textbook orders. It must accept the input of the number of textbooks required, generate the price per textbook, generate the total cost of the order, display the price per textbook and the total cost of the order. The The price of one textbook depends on the number ordered. So here we've got a table, we've got quantity and price per textbook. So this is quite important. So quantity 1 to 5, the price per textbook is 20. 6 to 9 is 15, and 10 or more, it's 12. Open Q03 in the code editor, write the program. So here is Q03, and the first thing we'll do is save that as Q03, finished. So the first thing we need to do is initialize variables. So what that means is we need to create the variables that we need in the program. So remember vertco, variables. Vertco, the V in vertco stands for variables. The first thing I need is variables. So I want to take quantity, and I'm setting these variables to 0. Price, which is a variable, that's going to change, so I set that to 0. And cost is going to set to 0 there. If we look back at the brief, up here, you've got price, cost there. So those are the things that we need. So that tells us what variables we need. Print prompt and take the number of textbooks required. So that would be quantity equals int, it's a whole number, input. Please enter the quantity of textbooks required. So I've opened 2 brackets, now I need to close 2 brackets. So now we need to generate and display the price per textbook and the total cost. So if quantity, this is our ifs now, is greater than or equal to 1 and quantity is less than or equal to 5. So you could have there greater than 0 or less than 6, it's up to you, but it needs to be 5 or less, not 6. So what is that then? Let's look at this table, they're £20. So price, not print, sorry, try again. Price equals 20. Right, what about the elif? Now the next condition, quantity is less than 10. So if it's 6 to 9 now, then price equals 15. And then my else. So basically, if it's 10 or more, price equals 12. So now we've done that, and we need to display the output. So cost equals price. So the price I've got now, whether it's 20, 15 or 12, times quantity. And now it's just a case of outputting that. So print the price per textbook is price, the total cost is cost. So we'll run it and see what happens, and we'll try the different inputs there. So we'll say, I want 4 textbooks, 20, good. Let's try it within the range 6 to 9. So always test it fully. I'm going to try 7, 15, 105, yeah, and run that again. So now we'll try a bigger number, 10 or more. So let's go with 11. That's £12 each. Okay, so that works. And that completes question 3 for a total of 6 marks. So always test your program. Don't just assume it's going to work. Question 4. Several encryption algorithms have been developed. State what is meant by encryption for A. Is it A, B, C or D? Is it conversion of ciphertext into plaintext? B, conversion of plaintext into ciphertext? C, conversion of code into data? Or D, conversion of data into information? It is, of course, B, conversion of plaintext into ciphertext. B, figure 1 shows a pig pen cipher grid. So here you've got the pig pen cipher grid, which kind of looks like, why is it called a pig pen? Maybe it looks like a pig pen. It's got kind of grid there, grid pattern there. You've got letters A through to Z, and each letter has a unique identifier. For example, L there has got the line across there and a line down there, and the big dot in the bottom right hand corner. So that's L, which is different to C, which has no dot. And then you've got the cross here, S, T, U, V, W, X, Y, Z, differentiated by the dots there. So each letter of the alphabet has a unique code. Complete the table by adding the symbol for each letter in the word may, M-A-Y. So M is the dot and it's the line in the corner. So M has the 3 lines there, so we can see it here, line, line, line. A, that's the 2 lines here with no dot, and Y is over here, it's kind of triangle shape on its side with the dot in it. So that's what we need to draw. I need to have the dot in that there, just make it as clear as possible. If you can, I would use a ruler for that and a pencil rather than drawing it hastily as I have. C, the message "the enemy is near" is encoded using a different encryption algorithm. Figure 2 shows the first stage of the encryption process. So you've got "the enemy is near," and you've got that listed out there in triangular shape, triangular formation. Now what kind of cipher method is this? This is rail fence. And we've got a key of 1, 2, 3, 4, 5. So we've got 5 rows. That means it's got a key of 5. So give the key using the first stage of the encryption process, where we counted 5 rows, so that is a key of 5. So with the rail fence, you're counting the number of rows, and that is your key. Give the ciphertext that is produced by the encryption algorithm, so it's just something you've got to go through that. So we look at that. TI, then HYS, so we write that out here. TI, HYS, then EMN, then we look at row 4, EEER, and finally NA. So make sure you write out that carefully and you go row by row like I did. 3, give the name of the encryption algorithm that is used to produce the ciphertext. It is rail fence. So that is the theory part of paper 2. So you can pretty much expect to get a question like that, usually on cipher methods or plain text into ciphertext and different kind of methods. You've got Caesar cipher, you've got rail fence, you've got Pigpen, and we also got Visionaire cipher that you need to learn for these kind of questions. So it's probably guaranteed that you're going to get something like this in any exam. And that finishes question 4 for a total of 4 marks. Question 5. Julie runs a computer gaming club. She wants a program to check the password stored in a file. The file passwords.txt contains a list of the passwords. So we're going to have a look at those files now. So here's passwords.txt, which is in the folder, and here's Q05A. They must be in the same folder. If they're not in the same folder, this isn't going to work. So you need to write a program to check each password in the passwords.txt. The first character needs to be an uppercase letter. If it is, it also includes at least 1 digit 0 through to 9. If the password doesn't meet these requirements, display the password and increment the number of incorrect passwords. So you display the total number of incorrect passwords after all the passwords have been checked. So it's got to read in the txt file, check the passwords through, and output the ones that don't meet the requirements. So first character is an uppercase letter, at least 1 digit 0 to 9. So this is Q05A, and we need to write our code here. So we can see we've got the alphabet there, A to Z in uppercase, and digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, valid digits, and password file equals open, passwords.txt, comma, and then R. R is read, so it's going to read in the file. It's not going to write to the file, it's just simply going to read it in and not do anything other than read the values into the program. If it was W, it would be write to the file, overwrite it. If it was A, that would be append. It would add any values to the end of the text file. So we're going to add our code here. So we need to create a variable called incorrect passwords. I'm going to use camel case equals 0. So I set incorrect passwords to be 0 at the start. So that's going to be added to as I go through the program. That's what's going to change. So for password, a variable called password in password file. So for each password in password file, valid equals false. So now we'll check the password. If password 0, so element 0, so the first element there is the first letter of the password, so we treat it as a string. So if password element 0 is in alphabet here, so if it's one of those letters, so if that's true, then we increment index by 1. So now going from element 1 onwards, we'll check the rest of the password. So while valid is equal to false and index in range, so from 1 to length of password. So now we're checking the rest of the password. Just de-indent that there. So now I'm checking if there's a number in there. So if password index, the value I'm looking at, in digit, so if the value I'm looking at in the array of password is in digit, then valid equals true. So it's a valid password. Else index equals index plus 1. So increment index and carry on looking. So what if the password is not valid? So if not valid, so if the password isn't valid, then we add 1 to incorrect passwords and print it off. So I add 1 to the incorrect passwords and I print the password off. Now I just simply need to output incorrect passwords. So this will print off exactly how many passwords are incorrect. Now, there's one more thing I need to do to get this to work. I need to close the file. So I need to write password file dot close. So you must close the file, otherwise it won't work at all. So now I saved it and I ran it and I've got an error. I've got a syntax error. I didn't close all 3 brackets there. So again, going back to the point we made earlier, always run your code. Otherwise, it's the only way you can be sure that it's actually going to work. So name false is not defined. So here, that should be a capital F. Again, a simple syntax error, but we need to find that. So it's told me that there are 6 passwords incorrect. So if we go and look at that file, just have a look at it, just see if that is exactly right. So we see 1 there, that is lowercase. Then we can see we go down, see another one there, 2 without a number in, keep going. So any without numbers or without an uppercase letter, 3, 4, 5, because that's got a number at the start, and I need 6. So what did it tell me? 5, and then I've missed 1. Yeah, that's 6 there. So these are the 6 that I haven't got. I can't see any more than that. Don't need to do that in an exam, but if you just wanted to check that, that works. So make sure that your code is in the same folder as password.txt, otherwise that isn't going to work. So we looped through every single one and we checked them that we had the correct passwords in there. So that is 9 marks. And how does that break down? Well, it's A1 to 9. So if your code didn't work, you might get marks for certain sections. So A1 is variable to store a number of incorrect passwords. A2 is using a loop. A3 is each password is checked to see if the first character is an uppercase letter. A4 is each password is checked to see if it contains a digit. A5 only check for digits if the first character is uppercase. A6 number of incorrect passwords is incremented correctly. A7 all incorrect passwords displayed. A8 text file closed, that's really important, otherwise it won't work at all in the first place. A9 number of incorrect passwords displayed. So that completes that question there. Moving on to B, figure 3 shows an array that stores player scores after a game. Julia uses a bubble sort algorithm to sort the scores. Complete the table to show how the bubble sort algorithm will sort the scores. You may not need to use all the rows. You won't need to use all the rows. That looks like way too many. So we'll go through that and loop through that and solve that now. How do we do that? So I'm going to write on here in pen and just show the process. So here's our list of numbers here. So in the first pass, so pass number 1 here, 3 and 2. So we should end up with 2 going there, and now 3 is going down the line. So 3 is smaller than 10, so 3 stays there. Now I'm on to 10. What I'm doing is checking n plus 1 against n, so n being my number there, n plus 1 being that number. If n plus 1 is greater than n, then they get the swap. The swap is made. That's a simple way to describe the bubble sort algorithm. So 10 and 8, 8 will be here, 10's going down the line, 1 will be there, 9 will be there, and 10 ends up where it should be on the rightmost side. So you're going to end up with the biggest number on the right hand side and the smallest number on the left. So that is the first pass there. I'm going to go to pass number 2. So 2 and 3 is okay, so that's going to stay the same. 3 is going to stay there because 3 is actually smaller than 8. But 8 and 1, they're going to get swapped because n plus 1 is smaller. So we're going to swap 8, 9, 10. So we can start to see we're already into, at least here, into the correct order. So we'll go on to pass number 3. 2 and 3 is going to stay the same because still not in a position to swap them. But now 1 and 3 are going to change. So that's 1, 3, and yet 8, 9, and 10 are going to stay the same. So that is pass number 3, and I reckon pass number 4 we will finish this. So pass number 4. So 1. So 1, 2, 3, 8, 9, 10 completes the number of passes there, and we did that in 4 passes. 2. Explain one reason why a bubble sort is very efficient in terms of memory usage. It's more efficient because the list does not need to be split, and you store half of the split, which you would get in a merge sort. So this would use more memory, having to store the split list. So that's why it's more efficient. Question C. Describe the steps a linear search algorithm takes to find a search item. Well, it starts at the beginning of the list, and that's 1 mark. It compares each value in the list with the search item, and it will repeat until a match is found or the end of the list is reached. So that completes question 5 for a total of 17 marks. Question 6. Carlos wants you to create a Guess the Animal game. Open Q06 in the code editor. The code contains an array of animals. So if we look at that, we can see an array of animals. We've got words there: antelope, ape, badger, bear, etc. It also contains a function that randomly selects an animal from the array. This is a secret word that the user needs to guess. So we can see generated words there. Carlos wants a program to generate the number of attempts the user has to guess the secret word. The maximum number of attempts is the length of the secret word plus 3. For example, the user has 8 attempts to guess the word when the secret word is tiger. So tiger is 5 letters plus 3 is 8. Keep track of letters from an incorrect attempts that are in the secret word and those that are not. There should be no duplicated letters. So all these bullet points are things that you need to do here. And just skimming over them. Check whether the input word matches a secret word, and there's some points there. Allow the user to attempt until they've guessed the word or run out of attempts. Display a message telling the user the game is over, including the random word if the maximum attempts have been taken and the word has not been guessed. So all the bullet points are things that you need to do. Figure 4 shows the contents of the correct word in wrong stores after 2 attempts to guess the secret word, cow. There's an example. And you've got some space for design there. You must include comments in the code which explain the logic of your solution. So it's really important that you do comment the code. Without that, you're going to lose marks. And you've got some space for design there. You do not need to fill that in. Some people do, some people don't. It's not always needed. You might want to draw yourself a flow chart. That's up to you. Just bear in mind that the time you've got, and you're not going to get marked for that section there. Total marks for this question are 20. So this is the big 20 mark question. It's usually question 5 or question 6. In this case, it's question 6. So we'll start here adding the main program, and then we'll do the sub-program. So we need to create our variables. So start with vertical. We create our variables, and we start off with word length equals length of word to guess. So we're already given that variable. So it's length of word to guess. Max attempts word length plus 3. So word length of 5 plus 3, that would be 8. They get 8 maximum attempts. Number of attempts taken is set to be 0 at the start. Correct letters, string. Wrong letters is a string. And guessed equals false at the start. So now we need to loop until there are no attempts left or the secret word has been guessed. Now at this point, I'd recommend to save your work. And it should be saved as Q06 finished. So we save as we go. So if there's any problem with the network or something goes down, something happens, we don't lose all our work and go back to square one, which wouldn't be very good at all. So I want a while loop here. Caps lock is on. Take caps lock off. So while should go on to remember. While number of attempts is less than max attempts, it's maximum number of attempts, and guessed is equal to false, so they haven't guessed it. We're going to output, so they have, so we're outputting the number of attempts they've got, so they have max attempts minus number of attempts, attempts to guess the secret word, so that gives them the number of attempts they've got left to guess that secret word. And we add 1 to the number of attempts. So now what we need is some subprograms. We need to validate the input. We're going to create a function called check input. We're going to pass into it a parameter p-word length and passed into that. So check input p-word length is our parameter. So that will validate input to make sure it's the same length as the secret word. Check is a string, and while length of check is not equal to p-word length, check equals input. Enter your guess. The secret word has, and then string length, p-word length, so convert that to string, so the length of the p-word, and letters. So how many letters it's actually got. Then we can return the check to the main code. So in main code, we'll call that function now, guess equals check input word length. So now, if guess is equal to word to guess, we're checking to see if the word has been guessed, and if it has, then guessed is equal to true. And we print an output message. So if they guessed it was true, well done, you've guessed it. The secret word was word to guess in number of attempts. So now we need the else. If it hasn't been guessed, check for correct words and wrong letters. So now what we need is another subroutine up here. And what that's going to do is check each letter in the guess for the right or wrong letters. So we're passing in here p-guess, p-word to guess, p-letters, and type. So we've created a function called check letters in word. So we've got type in there, which is a built-in Python function used to return the type of data stored in the objects or variables in the program, which you're going to need later. So for letter in p-guess, check each letter in the guess. So we're carrying out a check for correct letters. So type equals 0 now. So if letter in p word to guess and letter not in p letters, so if the letter is in the secret word and not in the correct letters, then add it. So we've done that now. So now we need to check for wrong letters. To our else here from our if further up. So if the letter is not in the secret word and already in the wrong letters, add it. So now we return p letters to the main calling code, and we need to call that function now. So now we need to call that function that we just created. Correct letters equals check letters in, I think that's capital I. I've double checked that. Did we call that capital I? Yeah, we did, so we need to have that here. And it's check letters, not check letter. So we need to get that right. Python won't tell us if we got that wrong, so it's really important that we double check that. So passing into that function, guess, word to guess, wrong letters. And our type, which is 0. So wrong letters. So now we're checking the wrong letters. Of course, check letters. In word, again, guess, word to guess. And this should be correct letters, not wrong letters. My mistake, apologies. This one is wrong letters. And our type, which is 1. Now, we're going to create a function called display to display all this. So correct letters, wrong letters. And we'll scroll up and we'll create our final function here. So def display p correct letters, p wrong letters. And that is plural there. So we're going to have a syntax error. Now we're going to display the correct and wrong letters. So if the number of correct letters is greater than 0, so print letters in the secret word, p correct letters. Now let's deal with the wrong letters. So if len, p wrong letters, and what I might do is just space that out a bit just so it looks a bit better. Add some white space in there, greater than 0. Same code as before, but this time p wrong letters. And I'll just take out the t there, p wrong letters. So now all that's left to do is the final point there, display game over message if the attempts have run out and the secret word has not been guessed. So that is an if num attempts is equal to max attempts and guessed is equal to false, print, so game over, you did not guess that the secret word was, and then word to guess. So now we need to save it again and we need to test it. So I did have a couple of syntax errors, like line 61 attempts. There's a beauty of interpreter there. It can tell you exactly where you've got your syntax error. I'm going to run it again and see if it works this time. It was all going so well till I found another typo, line 76, num attempt, which stopped working. So find, you get that find line 76 there, for example, and add the S. We'll save it again and run it again. Secret word has 5 letters. Let's try snake. The letter is not defined. Line 23. So let's go and have a look at that. And here's the typo. That should be lowercase. So fix that, save it and run it again. So this time we've got 9 letters. We'll try orangutan. So it's telling me that I didn't guess it, but I need to guess again. O and R. So why don't we try crocodile? And we guessed the secret word in 2 attempts. So the program works. So this is our full program for question 6. Now, things to note, make sure you do comment the code. You might not get the program to work. I would allow an hour for this big question, this 20-mark question, if you can. You have to realize that perhaps you might not get this to work. So let's look at how the marks break down for this. Say I couldn't get this to work. Now, we look at this mark scheme here. You've got A1 to A11, and then you've got mark band 1, 2, and 3. Now, to be in mark band 3, the code has actually got to work. So you can't get into mark band 3 with non-working code. What about mark band 2? The program meets most of the given requirements. I'm not sure, it depends on the examiner. I'm not sure whether they allow that, how good your code is. So you might be looking at maybe mark band 1, so 1 to 3 realistically. What if you got some of it to work? At least 2 appropriate subprograms used. Well, that's 1 mark. Repeat guess until the word has been guessed, or no attempts left, that's another mark. So A4, so A3, you must see working correctly. A4, request input of the word. A5, validate the input of the word. A6, check to see if the guess matches the random word. A7, if the word has been guessed, display message. A8, you must see working. A9 and A10, we've got to see working. A11, display lose message, including the random word. So what will happen is, when students hand me their work in, and they've finished this question, if there's a problem with the code, if it doesn't work when I run it, I first try and run the code. I press F5 and I run the code. If it doesn't work, then I go through this, and I award marks as per this guidance. So the program doesn't work, so I might award perhaps A1, A2, maybe they get A4, A5, A6, maybe they get A7. So there they've got 6 marks. Add that to mark band 1, I think realistically 1 to 3 marks, so pretty good code. They've commented it, but it isn't working. So finished program will function with some, but not all other sets of inputs. So we can't get into mark band 2 because the code doesn't actually work. So we're looking at possibly maximum mark band 1, 3 marks there. So we're looking at maybe 9 marks. That's quite a big chunk of marks and worth getting. So absolutely you must attempt this program and attempt to have a go at it. Try that out yourself and see how you get on with that code. But that completes this paper, and that is 20 marks for that question, and total for the paper of 80 marks. So as always, thanks for watching. Please like the video, please subscribe, and I'll see you in the next video. Thanks for watching. Bye bye.